Hello students, welcome to the next session of microprocessor. In the last lecture we have done with the what is microprocessor, and then we have studied about this code structure, means in this subject what we are going to learn. Now in this video we are going to study first with the microprocessor 8085 features, then later on we will study 8085 block diagram. So see, what are the features of microprocessor 8085? It is developed by Intel. Second point, it is a 8-bit microprocessor. It can accept 8-bit data simultaneously. So that's why we are calling it as 8-bit microprocessor. Now it operates on single 5-volt DC supply. It is designed using N-type metal oxide semiconductor technology. It has 6200 transistors on a single chip, which is fabricated on a single chip. It provides on-chip clock generator, hence it does not require any external clock generator. It operates on the 3 MHz clock frequency, has 8-bit multiplexed address or data bus, which reduces the number of pins. Now 16 address lines are there, hence we can address 2 power 16, means 64,000 bytes of memory. Now it generates 8-bit input output addresses, hence it can access 2 raised to power 8 256 input output ports. Next, it has 5 hardware interrupts: trap, RST 6.5, RST 5.5, 4.5 and INTR. It provides direct memory access technique. It is a 40-pin IC package which is fabricated on a single large-scale integrated chip. Its clock cycle is 320 nanoseconds. It has 80 basic instructions and 246 opcodes. Now, these are the features of microprocessor 8085. Next is the block diagram of Intel 8085. So in this is the block diagram. It consists of the following blocks. What are those blocks? Number 1, register array. Second is ALU and logical group. Third is the instruction decoder and machine cycle encoder, timing and control circuitry. Fourth is interrupt control group. Fifth one is serial input output control group. Now see register array. Register array means it includes so many type of registers. Number 1 category is general purpose registers. These are the user accessible registers. In this category we have, first, there are 6 registers B, C, D, E, H, L. These all are 8-bit registers. It can be used singly, means we can use B register, either C, either D, E, H or L. It can also be used in the form of pairs. When we are using it in the form of pair, then 2 registers becomes a pair, like B and C combination is there, D, E and H, L. Now these are 16-bit registers. Third point, it is used to store the intermediate data and the result. Last one, H and L, it can be used as a data pointer. We can say that it holds the memory address. It is used as a memory register. Now next category is special purpose registers, that is accumulator, instruction register and flag register. So first one, accumulator. It is the user accessible register. It is of 8-bit. Now, all the ALU operations are performed with reference to the contents of accumulator. Major point here is that when we want to perform any kind of operation, for example addition, then one value always stored in the accumulator and second is any of the general purpose registers. For example, we people are writing add B. So what is the meaning of this instruction? Add means it performs the addition. B, it performs the addition with the content of which one register? B register. So first value is in the accumulator and second value is in the B register, and ultimately result will store in which register? Accumulator. So result of an operation is stored in accumulator. It stores 8-bit data during the input output transfer. Next is instruction register. It is not user accessible. When an instruction is fetched from the memory, it is loaded into the instruction register, then transferred to the decoder for the decoding purpose. It is not programmable and cannot be accessed through any instruction. So next is flag register. It is the user accessible register. Now see, recently we have studied that result will be stored into the accumulator. Now when we are going to perform any operation, there is an effect on the flags, means it produces some kind of carry, some sign flag is there, some auxiliary carry, parity, carry status. So some different kind of flags are also affecting. So how? Flag register is of 8-bit. It indicates the status of ALU operation, means arithmetic logical unit operation. It includes 5 flip-flops which are set or reset after an operation according to the data conditions of the result in the accumulator. Means after producing the result into the accumulator, there is an effect on the registers also, on the flag register also. So this is the status flag in which total size is of 8-bit. See the bit number, this is 0, and when we are moving towards this side, then this is the 7th bit. So this is the sign flag, 0 flag, and auxiliary carry flag, parity flag, carry status flag. See, 3 fields are there which are don't care, means they are not used. These are undefined bits. Now see the detailed description of 5 flags. Carry flag. Carry is set when an arithmetic operation generates a carry out, otherwise it is reset. If it produces a carry, then we are going to set the value. Set means we are setting the carry flag to 1. Otherwise, we are going to reset that value. Reset means 0. Parity flag. Parity flag, when it will be 1 if the result of an arithmetic logical unit operation has an even number of ones. If there is an odd number of ones, then parity flag is 0. Auxiliary carry. It is similar to the carry flag. If auxiliary carry is 1, when it will be 1 if there is a carry from D3 to D4 bit, and it is 0 if there is no carry from D3 to D4 bit. It is not available for the user. Example, we want to add CB and E9. See, what is CB in binary notation? That is 1100. 1011, and what is E9 here? E9 is 1110, and this is 1001. Now add it. When we are going to add these both things, then what is the result will come up here? 1 plus 1 is 0 with carry 1. 1 plus 1 is 0 with carry 1. Here is coming 1. Again 1 plus 1 is carry. Result is 0, and here the carry is coming 1. Now you can see auxiliary carry, when it will be 1 if there is a carry from D3 to D4 bit. Yes, this is the D3 and this is the D4 position. So if here comes the carry, then that means this is 1, otherwise it is 0. So our result is 1011, that is 0100 with auxiliary carry equals to 1. Now 0 flag, if the result of an arithmetic operation is 00, then it is 1, otherwise it is 0. Sign flag, if the D7 bit of the A accumulator is 1, it indicates that the result is negative, then sign flag is 1. If D7 bit of the accumulator is 0, it indicates that the result is positive, then sign flag is 0. So that's what about the flags. Now what are temporary registers? W, Z and temporary data register. Now these are internally used by the microprocessor, but through user it is not accessible. Now it is of 8-bit capacity and it is used to hold temporary addresses during the execution of some instruction. Next is temporary data register. It is of 8-bit capacity. It is used to hold temporary data during ALU operations. Now Next is pointer register or special purpose register. These both registers are of 16-bit size. First one is stack pointer, second is program counter. Stack pointer, it holds the address of the data present at the top of the stack memory. It always based on what kind of principles? LIFO principle. That is last in, first out. Now, it is a reserved area of the memory in the RAM to store and retrieve the temporary information. Next, it also holds the content of program counter when subroutines are used. When there is a subroutine call or an interrupt, that is pushing the return address on a jump and retrieve it after operation is complete to come back to its original location. Next is program counter. It is used for the execution of the program. It contains the address of the next instruction to be executed after fetching the instruction. It is automatically incremented by 1. It is not much used in programming but as an indicator to user only. Next one is, in addition to register microprocessor, it contains some latches and buffer also, increment and decrement address latch. It is of 16-bit size. It is used to increment or decrement the content of program counter and stack pointer. Address buffer, we have total address is of 16-bit size. Now you can see we have two kind of buses. One is address bus, second is data or address bus. Because data is of size 8-bit. So, to reduce the number of pins, what we have done, we have used one technology here. We have merged the 8-bit data with the 8-bit address. So, that's why we are going to reduce the number of pins. Means we are multiplexing 8-bit data with the 8-bit address. So, address is here A0 to A15 and data is here D0 to D7. So, we are going to split this address into two, higher part and lower part. One is A0 to A7, second is A8 to A15. Now, you can see what combination we can make it out, that is AD0 to AD7. That is the address or data bus and this is the only address bus. Now, you can see this is the 8-bit unidirectional buffer. It is used to drive high order data bus, address bus. When it is not used under such as reset, hold and halt etc. This buffer is used tri-state high order address bus. Second bus is data or address buffer. It is a 8-bit bidirectional buffer. It is used to drive the low order addresses A0 to A7 and data D0 to D7. Under certain conditions such as reset, hold and halt etc., this buffer is used tri-state low order address bus. This is the low order, this is the high order address bus. Next is ALU and logical group. It consists of ALU, accumulator, temporary register and flag register. Now, ALU, it performs arithmetic and logical operations. It stores result of arithmetic and logical operations in accumulator. Accumulator, it is a general purpose register. It stores one of the operand before any arithmetic and logical operations and result of the operation is again stored back into the accumulator. It stores 8-bit data during input-output transfer. Temporary register we have studied recently. During the arithmetic and logical operations, one operator is available in accumulator and other operator is always in the transferred to the temporary register. We have studied this instruction recently, that is add B. Now, flag registers we have studied. Next is instruction decoder and machine cycle encoder timing and control circuitry. First, decodes the operation code stored in the instruction register and establish the sequence of events to follow. Second point, it encodes and transfer to the timing and control unit to perform the execution of instruction. Timing and control circuitry, it works as the brain of the central processing unit. For proper sequencing and synchronization of all the operations of microprocessor, this unit generates all the timing and control signals which is necessary for the communication between microprocessor and peripheral devices. For example, our microprocessor wants some input signals. Then our control signal will goes to the peripheral devices. Which kind of peripheral devices? To the input devices. So in this way this will work. Next is interrupt control group. Interrupt means occurrence of an external disturbance. After servicing the interrupt, 8085 resumes its normal working sequence. First we have to service the interrupt, then it will return back to its normal working sequence. Transfers the control to special routines. 5 interrupts are there: trap, 7.5, 6.5, 5.5, INTR. In response to INTR, it generates interrupt acknowledgement signal. Last group, that is serial input output control group, it is used for data transfer D0 to D7 lines, that is for the parallel data. But under some condition it is also used for the serial data transfer. Serial data is entered through SID pin, that is serial input output input data, that is the received pin. Serial data is outputted on SOD, that is serial output data, that is the input pin, send pin. Right. So that's what about this block diagram. In the next video we will study about the 8085 pin diagram. Thank you very much.